Welcome to a tester for our coronavirus isolation time period. So I'm just practicing to see how well it will go. And today we're looking at C3.1, further area of volumes of revolutions. And pretty much we need to look at rotating all different functions, including, regions between two curves about both the x or the y-axis. Okay, the x or the y-axis. And I've done a few examples for this, so let's see if this actually pops up. Of course it doesn't screen mirror now, but look at that. Okay, there she is. So I've done a few examples on this already, and we see that if we are going to be spinning the shape around the x-axis, we use our volume equals pi times the integral of y squared dx. Okay, and if we're using the second formula, we could use pi by the integral, doesn't matter, we'll find what the bounds are, of x squared dy if we're revolving around the y-axis. Okay, so if we see this in practice, here is an example that says straight away 2001 question 7. These questions were from 2 unit before our current HSC, however they got moved to extension. The part of the curve x squared over 2 plus y squared equals 8 that lies in the first quadrant is rotated about the x-axis. So there's our curve, it's already given it to us. And we're going to spin it around the x-axis. So we often see a symbol that it's spinning around the x-axis, and we could see what shape it will form. It will make this cool. That shape there is going to be spinning around. So I'll make that kind of shape there as it spins around. Obviously, it doesn't go on this left side of the axis. I was just trying to make it look 3D. Okay, so as soon as it says around the x-axis, we know we need to use y squared dx. Okay, and the limits that we will use, our a and b, are going to be here from 0 along the x-axis to, well, need to find out where this is going to reach, this x-axis. So we're going to find when y is equal to 0, what is x. Okay, so let's rub this off, and we'll write that first because we'll need to know that for that formula. So when y is equal to 0, we'll say x squared over 2 plus 0 squared is equal to 8. Okay, because the y has been replaced with 0. So now we can just solve this, and that's nothing, so I'm going to ignore that. And then we're going to multiply both sides by 2, so x squared is equal to 816, and then therefore x is going to equal to plus or minus 2. Square root of 16 is 4. However, this graph, we actually aren't doing the rest of this shape. Okay, it's close to a circle, but it looks like, as you can see, it's going to be more like an ellipse. In this graph, we're only going to use plus 4. Okay, and the other thing we're going to need to know is, because we're going to go work out what y squared dx is, we're also going to find this here also. Let's have a look. I'll just put it next to it. That if x squared over 2 plus y squared equals 8, therefore y squared is equal to 8 minus x squared over 2. Okay, so we're going to use these two things. X is equal to 4 and y squared is equal to 8 minus x squared over 2. And we're going to sub it into v is equal to pi by the integral of between a and b of y squared dx. Okay, so give some more space. I probably should have moved it underneath that, but that does okay. So the integral between 0 and 4 of 8 minus x squared over 2 dx. There we go. So this is what we've got, which we can easily then solve and get pi by 8x minus x cubed over, well, the 3 would normally go down if it was differentiation, but obviously it goes underneath for integration and multiplies by the 2 to get 6 between 4 and 0. Okay, so if you differentiated this, it will become 3x squared over 6, and the 3 over 6 is going to get us out 2. And therefore, we can now do pi by, let's have a look, when 4 gets substituted in, we get 8 times 4 minus 4 cubed over 6, which is I could practice using my little calculator, make sure it's there. There you go. You can see my games on the desktop. Okay. So 8 times 4. I probably should have kept actually 8 times 4 minus 4 cubed over 6. Okay, so 64 over 3 is that part. And because now I could go through and then substitute 0 in, but I know that if I did that, I'm wasting my time, because we get 0 cubed, and then this 4 is also a 0. But it's good practice to be able to make sure, as we wrote them in, we could just go through and just substitute the second one in here, because we don't always get 0. Okay, but yeah, of course that is 0. Okay, and that's why we get 64 pi over 3 as our answer, and that is in cubic units, because we're finding a volume. Okay. I like that screen, that little calculator there. I should keep that there for the whole time. Now let's do a second question. I actually did one of those in class, and I started doing this, so might do this because I did the previous one in class previously. So I'll rub off this and then show you. I've only half started it. Okay, so this is a 2005 question 6, and it asks us to rotate about the y-axis, this shaded area. Okay, so we know we're going to have to use the volume is pi by the integral of x squared dy. Okay, because it's dy, we're going to spin around the y-axis, dy, and we always use x squared dy. for these volumes. Okay, so the graphs of the curves are y is equal to x squared, so we know this one is concave up one, and 12 minus 2x squared, so it's 12 is its y-intercept, and it's got a concavity of -2, so it's concave down, and it's been compressed in. Find the points of intersection of the two curves. I did this already to show. Just make sure that when you solve this, we found that they have, it's when x is plus or minus 2, so you solve when do they have the same y values, when y is equal to x squared, or when y is equal to 12 minus 2x squared. They've both got the same y values at when x is 2 and when x is -2. Okay, so along the x things, and you also have to make sure that you're showing the actual coordinates from that. So 2 across is up 4, and also -2 across, so left 2 is up 4. So we know the points on the graph. So you don't need to write them on. It was already gave a picture, but 2 across and -2 across were both up 4. Yeah. Okay, and then we're looking at this 3-mark part. The shaded region between the curves and the y-axis is rotated about the y-axis. Okay, so the shaded region between these two curves and the y-axis, they just gave that to specify this little shaded part by splitting the region into 2 parts. That's why you saw the colours earlier, or otherwise find the volume of the solid it formed. So I started and did the red part already, so this was the top line. Okay, so I know that I'm going from 4 up to 12 up. Okay, so my limits for the integral is from 4 to 12 for this red part, and because I hadn't finished it, and I can see I've got 2. So look at that. So it should be from 4 up to 12 up of x squared dy, and you can see that for the graph x squared is 6 minus y squared. Okay, so this is where, if I use the calculator, I can easily just go back in and sub it a second time. So I can go 6 times brackets 12, and then I know I just change the parts in that brackets, minus 12 squared over 4. So that's 36 as the first, pi by 36 minus, and then I can just go back, use the arrows and change it to 4, and change this other part to 4 as well. Okay, so 36 minus 20 is 16, so 16 pi. Now, I said I only half did the question because that only found the red part in this that was spun around, so that would find like this top section that's been spun around, and we also need to add this green part there as it's spinning around the y-axis, and that's between 0 and 4. Okay, and that's our x squared. So the green part, you can see I've got the answers down there after anyway from HSC, but we won't do that. But the green part's going to be volume is the integral pi by the integral between 0 and 4 of x squared dy, when y is equal to x squared. We know we can just replace that with pi by the integral between 0 and 4 of y dy. Okay, I've just replaced x squared with the y, because x squared is equal to y for this graph here, for this part, and that means we're going to get, I've left the spacing, so we're going to get pi by y squared over 2 between 4 and 0. Okay, I'm not going to bother using the calculator for that, because I know that the 0 is going to be nothing anyway, so we'll get pi by 4 squared, which is 16 over 2, which is 8, minus 0, which is of course 8 pi, and therefore the volume is, say, let's just put this as volume 2, and then put this one as volume 1 for our marker, to know that it's equal to volume 1 plus volume 2, which is 16 pi and 8 pi, and give us our final answer of 24 pi cubic units. Okay, and hopefully we got the same answer, 24 pi cubic units. Look at that. Now see what they've just got there. They've done it as one part together, and that's perfectly fine. So looks like I didn't check the answer first at the start, but that's the same. So this is, I put that as volume 2, and then that was the volume 1. I don't like that. Yeah, I guess I can do that part. That's okay, but see how they've shown the answers? They've even shown that minus 0. I know you guys didn't want to always show the minus 0, but it's important to substitute in so we don't lose marks for these different parts. Did it ask for 3 significant figures? I should check the question. I didn't read it all. No, it didn't ask for 3 significant figures. I don't know why they did that, but you know, just remember, if you did want significant figures and you did 24 pi on the calculator, the most significant figure is the first one from the left that's not 0, which is the 7. So 3 significant figures is 75 point, and then 4. So the first, the second, and then the third significant figure is that tenths column there, which is rounded to 4. So that's why they've done that. That's 75.4. Notice they don't write u cubed as it gets confusing as we start substituting integrals and using u as a substitution. So I write cubic units. They write units cubed. It doesn't really matter. I just find that cubic units doesn't confuse students as much. Okay? Hope that video is a good practice video for me. I'll stop it.